Say again, sorry. 42. U and V are mutually exclusive. What can you write immediately? Probability of U and V equals 0. Kick ass. So look at the very first question they ask you. You should look at that and go, ha 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 ha, you fool. Right. You say, you've given it to me. Right? So part A is done. It answers its own question, but the mistake people make is they go to part A, they do 0.26 times 0.37, which is not any of the formulas we did, right? And then they just keep going, la la la. The first question, the first statement is the most important. It gives you all the information you need. You can only, let me see who can answer this. When would the probability of A and B equal the probability of A times the probability of B? When can I just straight up multiply and get the and? Does anyone know? All right, let's take a step back. What is the formula for probability of A and B? You can look at your notes, you can look at your whatevers. Kick ass, right? Probability of A and B is probability of A, for example, times probability of B given A, or the other way around. So when is the and just equal to A times B, probabilities? When is that true? When is that true? What would have to be true about this? Because that's what it is. That's the formula for it. We created it. We saw it. There it is. So when is this true? What has to be true about what has to be true? This is the formula, correct? So when is this true? When that equals that. When is that true? If they are independent events, correct? If you don't know they're independent, you can't do that. Does that make sense? The formula for and, does everybody agree with this next statement? The formula for and has a given in it, correct? Does everybody agree with that? Anybody not agree with that? It's a great place to start. Because it just does, right? That's the formula. We created it, we saw it, we used it, we saw why it made sense. So the only time you could just multiply two probabilities directly together to get their and is if you know they're independent. Did the problem say that those are independent? No, in fact, it said the opposite. It said they're mutually exclusive, right? Does that make sense? So you can't just multiply two probabilities together to get their and, because the formula requires a given, right? And we saw why this makes sense. If I have a bunch of people in a house and I take one out and I let them leave, then the next probability changes, correct? Given that I did that, the next probability changes, correct? If I put them back in the house, they're independent. Does that make sense? It resets. If I take a chip out and I put it back in, does everything care what I just did? No, it's as if I did nothing. I just put it back in. Does that make sense? So that is an example of an independent state of events. The next chip I picked doesn't care. Now, if I picked one up and I threw it away, does the probability change for the next chip? Yes, because the number changed. The denominator is going to be different. You guys with me? Okay. So 42. So everybody cool with 42A? What's the answer again for 42A, just to give it away?
0.
Give it away now. What about B? What's the formula for probably U given V? It's sort of up there, but not really. What's on the top of U given V? The formula for the probability. Say again, sorry. U and V, right? The probability U and V divided by, who gives a shit? Because what's the probability of U and V?
0.
Okay, so part B is pretty straightforward. I don't know if you guys are with me. So again, the first sentence, they are mutually exclusive, which means I immediately can write this. Part A, 0. We just said that, not 0 factorial in case you know this. Part B, what's the formula for U given V? could do it. Somebody tell me. Help me out.
U and V.
Good. The probability U and V divided by
V.
probability V. I love it. But what did we just say U and V is?
0.
Divided by who cares? Right, that's not 0. That's all that matters. So the answer is 0. Good. That is exactly like the silly example of I have a room and in it is a bunch of bowls of ice cream and a bunch of rocks. Right? Let's say there's 12 bowls of ice cream, 12 bowls of rocks. 12 bowls of rocks. Sure, why not, Jeff? You with me? If I pick up a bowl, what's the probability it's a bowl of ice cream? There are 12 bowls of ice cream, 12 bowls of rocks. I pick up one bowl and blindfold. What's the probability I picked up a bowl of ice cream? 50%, right? I take a bite. Ah! There's rocks in there, right? What's the probability it's a bowl of ice cream now? 0. So if they're mutually exclusive, bless you, they're completely dependent. If one thing happens, can the other thing also happen? No, they're freaking exclusive. They're mutually exclusive. I don't want to get too deep into that, but they're sort of polar opposites. Mutually exclusive is the most dependent you can be. Because if they're mutually exclusive, if you're one thing, you have no chance. The probability of the other thing happening is now 0, right? And that's what you find when you do this problem. Part B is 0. There's no chance. Given that V happened, how could U happen when they are mutually exclusive? There's no chance. Does that make sense? Okay. I went way further than I need to, but oh. So all those problems, I think every single one of those problems, the very first sentence gives away like over half the what you need, right? Is that okay? Is that better?
Yeah.
Okay. The only people reacting are like very minimally, yeah, sure, Jeff. Okay.
How about 43? That's the one.
Oh.
Yeah.
What can you write immediately? That's funny because I forgot they were Q and R, and I think I had Q and R. From the very first sentence, what can you write?
Q and R equals 0. Well,
Probability of Q and R equals 0, right?
but it's independent.
No, I'm sorry. Independent, yeah. So what can you write? This,
Yeah.
right? I'm not going to, holy crap, get out of there. I'm not going to do much of this one. What do they give you after that? They give you the probability of Q, the probability of Q and R, correct? You with me?
Yes.
And then they ask me for the probability of R. We don't have a formula for the probability of R, do we? No. Do we have a formula for the probability of Q and R? Totally. So I would write that and then see how I can use what they told me in what they asked me. See if anybody remembers. What's the only time that the probability of A and B equals the probability of A times the probability of B? What's the only time that's true? If they're independent. And that's the last thing I'll say. I just basically told you how to do number 43.
Can you explain 42C for OR?
Real quick, anything else on 43?
Yeah.
Okay, well. So, real quick, if I knew A and B are independent, right? And I told you that this is 0.7, and I told you that this is 0.9, could you figure out what this was? Okay, now I've really told you exactly how to do number 43. Totally just did. All right, if it still doesn't make sense, see me after. Okay. What else have we got? Sorry? 42C.
It's because I know OR is different.
How do you mean OR is different? What's the formula for OR?
I'm sorry.
No worries.
Yeah, you gotta add them.
Add what?
The U or V.
Probability of U. Keep going.
Plus V.
Plus probability of V.
Yeah.
Minus.
Probability.
What's the OR formula? You add them, subtract any that are.
Minus the different one, right? No, it's A and B.
minus the probability of A and B. Right. So this problem, U or V would be probability of U plus probability of V minus the probability of U and V. From the very beginning, what did we say probability U and V is? 0. Okay. Part C is easy. Because don't they tell me U and V probabilities?
Yeah.
Okay. So again, you guys have got to trust. Part C is an OR question. Don't we have a formula for it? The immediate thing to do is write the formula down and then step back and go, what do I know, what do I not know? Right? You with me? A little bit? Just like any math class, it'll keep coming back. Here, real quick. You're not going to have specific probability questions like these exactly. The big thing that chapter 3 shows us is the basic idea of probability, and this. And means multiply, basically, or means add, basically, right? Those are the huge, if you remember those things, a lot of what we're about to get into will make more sense. So again, 42C, write the formula for it, and you know all the values of everything the formula needs, so you can do it. I still have people looking at me like I'm crazy. What is the probability of U or V? What's the formula? I know I just said it, but let's write it. V, what happened to you? What is the formula? Probability of U plus minus U and V. Don't we know all those?
Yeah.
Okay. So, but again, the biggest mistake people make is they don't realize that you know this before you do any calculations. They just told us what that is. And they told us what PU and PV are. So they could have asked me part C right off the beginning. Could have been the first question they asked me was part C, because they already gave me everything. Does that make sense? Okay. And again, if it doesn't make sense, that's fine, in the sense that you can ask follow-up questions. You can see me later. You can do whatever. Yes?
Oh, can we like do some problems from the practice?
From the what now?
The practice quiz?
Sure, of course.
Number 3. All of it.
So real quick, anybody in here did not get this worksheet here? Because one side has the practice quiz that we're having the quiz on this Wednesday. Let me know if you need this sheet. Because part of today is going to be going over this practice quiz if you want to. Or we can leave your friends behind. Because your friends don't dance and everything. So what you got? Let me know if you need this sheet. Okay. Last time we did all this. Okay. So where are we at, Ocean?
I'm confused on number 3.
Number 3. Oh! Yeah, you can tell how often I update my little worksheets. So this is a lot like that problem on the other side, this one. The one about brown cows. How now, brown cow? Making chocolate milk? So, how many little blank spots am I going to make? Because I want the first two to dislike the plan. The word but is also the word and, right? Do you guys understand that? English is weird. First two dislike it, and the third one likes it. So I want the first one to not like it, and the second one to not like it, and the third one to like it. Does everybody see that? And means blank, and means multiply. I love it. So how many little blank spots are you going to make there? That makes sense. 3. Because we're picking 3 people, correct? Picking 3 people. This guy's going to do something, and this person's going to do something, and this person's going to do something, right? I want the first 2 to dislike the plan. So what probability am I going to put in there? 0.33, right? The first 2 don't like it, but the third one likes it. What's going to go here? 0.67. Where'd she get 0.67 from? The rest, right? You guys see that? So the funny thing is, if I have such and so many things and I want each one to do something, so this one does something, and this one does something, and this one, and means multiply, and then you just fill in each spot exactly related to what you want them to do. I want the first 2 to dislike it, but the last one to like it. This one dislikes it, and this one dislikes it, and this one likes it. So now I just got to throw that in the old calculator. The old calculator. So I think it's 0.07 and then something. I don't know. What is it? 0.073.
It was 9, but it rounded up, so 3.
0.07. 29. 63. Okay, so then I would accept this. Okay. Remember how many places for probabilities? 4 places decimal. I like it. I like it. And then it's up to you if you want to make it boom. You can make it into a percent. You can make whatever sound effects you want. You can make a 3 look like a 3. Good Lord, Jeff. Bam. Okay. Is that all right?
No, where'd she get the 0.67? That's what I'm.
Oh. If 33% don't like it, how many like it?
Oh, like out of 100, basically.
Yeah, always out of 100, right? Yeah.
That's what.
If there's a 33% chance of rain today, there's a 67% chance it won't rain today, right?
Got
Okay.
it. All right.
Now, to be really honest, the poll was more like levels of liked, but I just grouped all the disliked and grouped all the liked. Okay. To make it a much more, just a just a 2 outcome possibility. Is that all right for that part?
Yeah.
C's where things get interesting, but if you do part B, then part C is easy as shit. The reason I say that, guys, anytime I ask you a probability question, any probability question, and the opposite probability is easier, you figure out the opposite probability, and then you do 1 minus that. Yes? Again, if somebody tells me the chance of rain today is 30%, can I calculate what the chance of not rain is? I just do 1 minus that, correct? So if it's easier to calculate the opposite of something, I'll do that and do 1 minus that. And then I'm answering the question, right? So look at part B. All 3 dislike the plan. What would that look like? I still got 3 people. I'm going to do 3 little hangman spots, right? Like I'm playing the game Hangman. Connected by times, because it's and, correct? I love you guys, okay? So what am I going to put in each spot? 0.33, 0.33, 0.33. And of course, mathematically, this would be the same thing, right? 3 to the third. And do you see how that makes sense? 3 people that do this. 3 people dislike. Bam, right? And then, whatever the shit that is. That's going to be 0.0365? 59? 0359?
Yep.
I feel pretty good about that. Now, part C is desperately easy. What's the opposite that at least one likes it? What's the opposite of at least one likes it? No. If they all like it, does at least one like it? Yes. So what is the opposite of at least one likes it? Nope. I love you guys so much. If I said at least one person in here likes the way I teach, how could you show that I'm wrong? You'd have to show me that nobody. likes the way I teach, right? If I say at least one, you're like, well, I talked to 5 people, they don't like it. Does that mean that I'm wrong? Could it have been somebody else? So the only way to say at least one is wrong is to show none. Does that make sense? Does that make sense? Let me do it the other way around. If I said nobody in here likes Brussels sprouts, what would it take to show me I'm wrong? At least one. Hey, there you go. They're opposites of each other, correct? So, I could, and I'm not sure if you guys really understand how much work it would take. This is a specific one likes it, the plan, right? This one is specific, one likes it. You with me? Doesn't one person like it up here? Okay. So if I want to do at least one directly, I have to do the probability of one likes it, and that could be the last one, or the middle one, or the first one. Then I have to do the probability 2 people like it, and that could be the first 2, or the last 2, or the first one and the last one. Then I have to do the, holy shit, the opposite probability is none of them like it, and we already did that work, didn't we? Do you see that? So what's probably at least one likes it? It would be 1 minus, none of them like it, we already did that. We already did it, right? So then whatever, remember the shortcut? I don't know if did I tell you guys the shortcut to do this by hand? What makes 0, 9, 9? What makes 3, 9, 6? What makes 5, 9, 4? What makes 9, 10, 1? That's true. Let me pull this up. So in general, if I have to calculate a probability and the opposite probability has less work, I'm going to do that and then do 1 minus my answer. Much better way to do it. Okay. I really never want to play poker with some of you guys. You got like less than 0 reaction. It's interesting. It's like a reaction black hole. Does that make any sense, or is that complete bollocks? So again, let me try this one more time. We have 3 people at most here, right? You with me? How many could like the plan? None of them? 1 of them? 2 of them? 3 of them, correct? If I add all these probabilities up, don't I get 1? I have to get 1, correct? So another way to write this, the probability is 0. I know I did this last time, but again, I really want to show you this. Equals 1. Yes? Is everybody cool with that? If you add up all the probabilities in a given situation, it has to be 1 unless you round it. But here I'm just saying if I knew perfectly what all those were, they'd make 1. Is that cool? You guys with me? I know I did this last time, but can anyone tell me in this string of weird shit which part of this is the probability of at least 1? Which part of this means the probability of at least 1? Could be multiple things, right? This is at least 1, correct? Is everybody with me? So I could rewrite this probably 0 plus probability of at least 1 equals 1, correct? This has a lot of work. This has very little work. Can't I just solve for this by subtracting? So if I figure out the probability of none, the probability of at least 1 is 1 minus that. Maybe? Yes?
How does that find our answer though? Or is it just...
Because real quick, because this is the question in part C, correct?
Okay.
That's the question, right?
Yeah.
This is the answer to part B, right? None of them like it in part B, correct? Cool. So the answer to part C is 1 minus the answer to part B. Bam, right? I really want this to make sense. So if I had 80 freaking people, and I want to know the probability of at least one person does something. Holy shit. Holy shit. You'd have to do the probability of one, and it could be the first person or the second person or the third person or the fourth person, 80th person, plus the probability of two, first two or the last two or the middle two or the first one and the seventh one or the 11th one and the 18th one or the holy shit. Do you guys understand? That would be a lot of work. Do you guys understand? The probability of at least one means it could be one, and then it could be any of the 80, correct? You'd have to do each one of those. Or it could be two, correct? At least one. First two, last two, middle two. It would take forever just to figure out how many freaking ways there is to do that shit. Or I could just do one minus none of them. The same way if somebody says, what's the probability it's going to rain today? You can do one minus probably won't rain today. Same way. Okay. Maybe, maybe not. Okay. By the way, while I'm thinking about it, I did not print out the answer key just because I'm tired of using paper. So it's already active. Did I activate it in your class? That's a good question. Whoever's thinking about that. Hold on. I just did it right before class started, but I think I only did it for my other class because I'm a jerk. Hold on. Now I gotta remember my password. Shit. Will he do it? He probably won't. No, I won't remember my password. No. That's fine because I have to go back to my office real quick anyway in a minute to get another worksheet. So when I do, I'll put it up on Canvas. So I've got the answer key for this. I'm going to put it in Canvas. You guys all with me? I think it's there. If somebody wants to check, I think it's in the modules under the handouts. I'm not sure if I published it yet or not. All right. It's not? Okay. So I just gotta activate it for you guys. Okay. Anything else from this sheet here? So just make sure everybody understands the answer key for this is going to be up on Canvas. Right. But right now we could go over any part of this that you want to.
No, it's there.
Say again? It's there? Thank you. So it's under modules and it's practice double quiz answers or something like that? Is that right?
Practice probability worksheet answers.
Beautiful. I think it's the very first thing in there, right? Yeah, okay. Yeah.
For A and B, they're just placeholder, right?
A and B.
A and B, in the equation and stuff.
Oh, totally. Just like any equation, right? Do you guys remember the quadratic formula equation? Even if you don't, do you remember there was an A and a B and a C in it? Negative B plus or minus the square root, blah, blah, blah. So they were just placeholders for numbers you would plug in. So what do the variables in probability, what are they? Capital A, capital B, what do they hold the place of? The events. So P of A is the probability of event A. So if wherever I see that, I can just put the number that represents that probability, right? They're just like regular variables, yeah. Okay. That's why we did the whole U and V. So the probability of A and B gives me the template, and then I just fill in the U and V in place of A and B because they're just variables.
So what are U and B?
Events, yeah. So we use capital letters. So U could be the event that somebody, shit, that somebody went underground. I don't know. Somebody starts with U. All I can think of is Uranus and underwear. That's all I can think of. So U, some U thing, and then V could be probably somebody plays violin.
Yeah.
So we pick the letters to match with some idea of the event.
So basically, we just use A and B or any other.
Yeah, it's just like X and Y and algebra is just the main two.
Idea, and then the other letters, like
They would just fill into the,
side. Okay.
yeah. So if you got a formula for probably A given B and you want to know what U given V is, replace A with U and B with V. All good. Yes, good. So let's do this real quick. We basically already did this, but just to make sure everybody understands, we're gonna write down the formulas you're allowed to have. If I have paper, let's see. Yes. What are you? Nothing. Okay, good. I think you're nothing. You're short of something. Okay, let me. All right, beautiful, perfect. So we already did this, but just to make sure everybody's got the right stuff. A or B. Probably of A plus probably B minus probably of A and B. Ruh-roh. A given B, like we saw earlier, is the and divided by the given. The one that's a little weird, but you got to remember there's two ways to get this. It's either, and is either PA times PB given A, or it's PB times PA given B. Either way. So those are all the formulas you need for Wednesday. Is there any other formula you think you should be allowed to have? I'm open to suggestions. Yes?
Do we need the independent?
Those aren't formulas, those are ideas. So those are ideas you must know. Right? So I don't want to see anywhere on your formula sheet A and B, mutually exclusive, probably have A and B equals 0. That's not fair. Is that cool? So you have to understand what mutually exclusive means, you have to understand what independent means. Is that all right? So watch this. Everybody got that? I mean, we've already made this sheet last time, right? Can somebody tell me? Okay, beautiful. Look, see, I'm going to another sheet of paper. Okay. Can somebody tell me the formula for the probability of L given S? Probably of L and S? S, I love it. So just like you were saying back there, the A and B are just placeholders. They give you a template. So the specific variables I'm given for a problem, I can just replace them. Cool, I like it. Just like X and Y, they're completely arbitrary why they were X and Y. There's a bit of a history to X, and then we said, what about other shit? What's the next letter? Oh yeah, we'll just use Y. That's the drunk history, but it's pretty close. Yeah.
Would it be a no on writing just like the name of the formula? Is that thing like not what it is, just the name of it?
That's what it is. So no words, except for or and and. And you could title it formula sheet, and you could put your name on it. Okay. I like it. So another sheet of paper, right? If I tell you that W, I don't know. There's not. If I tell you that happy face and triangle are independent, can somebody tell me anything you know? Probability of happy face given triangle equals? No. Happy face. I love it, right? Again, happy face is not a traditional symbol we use for an event, but I'm getting tired. Every time I do, I use W all the time. Because my last name's Waller, maybe. I don't know why. I go to W. Good old happy face and triangle. Okay. You guys with me? You know I'm going to put something like that on the quiz. You know I'm going to do it. I'm going to say, these are mutually exclusive. And then you have to remember, that means, what would that mean? So if I have alpha and beta are mut X, mutually exclusive. What can I immediately write down? Alpha and beta. The probability is 0. Okay, cool. And then I could do shit. If I ask you a question, you write the formula down. Wherever you see this, 0. Kick ass. Enough of that shit. Okay. So that's the formula sheet. Okay. Anything else from the practice quiz? And again, it is up in Canvas. It's in the handouts. I think it's in the handouts module. Should be the very first thing up there right now. The answer key. Okay. Okay. No other questions from this? Okay. Yes.
For one of the formulas, there's multiplication. What?
Sorry.
One of the formulas is multiplication. Or,
That's true.
what's the trigger for that, like question and stuff like that?
What?
That formula?
Any formula that's required that's wants you to do that something and something else. And I've shown you several times. If I said I pick two people and I want them both to be Democrats, so say a probability of two Democrats. Do you understand how that's an and?
Yeah.
Even though I don't see the word and. Because another way said is Democrat and another Democrat. But in English we just go, it's two freaking Democrats we talk. Right? So the word and is very often hidden. So if I see the word but, like we saw in the word problem, that's another name for and. If you replace but with and, it works. Okay. I could do that, but I don't want to. I could do that, and I don't want to. Same idea. Right? Okay. Anything else from this practice? All right. Y'all look very excited about Wednesday. Okay. You know I'm going to give you a problem with this. You know it. And what's the very first thing you do in this kind of problem? Add up all the stuff. Okay, I love it. Right? If your answer is 3 over 11, if that is your answer, why is that not right? It's not 4 decimals. Just, that's your work. Now do the decimals, yeah? What if your answer was 1.2?
No.
Why not?
Can't go over.
Can't go over 1, yeah. So if you get 1.2, if you do all this work and you get 1.2 and you don't know why you're getting it, do this. I know it shouldn't be 1.2, but I can't see why. Because I will take less points off if you at least show me that you know it shouldn't be that. If you put 1.2 and just circle it, like, yeah, 120% chance, I'm like, oh, that's a problem, right? Does that make sense? So I'm okay if you do something wrong, you're like, you can't see it, just go underneath, go, I know it shouldn't be 1.2. I don't see why. And I'll give you more points for that. Okay. Or at least I won't take off more points because you're at least showing me you know it can't be that. Okay. Okay, that's enough about that. So that's going to happen first thing Wednesday is this double quiz. Okay. Something to look forward to. Let me give back a bunch of stuff real quick, or else I'm going to forget to do it entirely. I'm going to use it for scrap paper. Eliana? JC? Hey. Jaden? Bella? No. Test. Everything is due the day of the next test. And this is not a test. Tegan? Emma? Ocean? Riley? Taylor? Cherish? Nora? Alex? Paris? Alex? Yesenia? Elena? All right, guys, so we're about to get into chapter 4. Yeah. Of course, it comes right after chapter 3. It's crazy. So, the double quiz on chapter 3, Wednesday, first thing. It's just a quiz, so today's not just review day or something. Just did a little extra review because it's a little longer quiz. Let's put you down here. Let's turn you off. Sleep. Okay. That'll work. Okay. So, what we're about to do is, we're about to get into a series of different ways for us to be given data. The most basic way for us to be given data is just somebody gives us a comma, separate a list of data, correct? We've seen a lot of problems like that, right? The next way of giving us data is if my data has a lot of repeats. So I could give somebody, say, 20% of my data is zeros, 30% of my data is ones, and so forth. Are you guys kind of with me? Because if I have 1,000 data points, I don't want to write 200 zeros. Zero, zero, zero. No, I'm just going to say 20% of my data is zeros. All right? You're going, okay. You guys are sort of with me. So instead of getting a complete list of every individual data point, somebody can just give me a number and how often it shows up. So what we're going to do is we're going to say, I don't want to write. If they tell me that 10% of my data is zeros, do you really want to write 10 zeros and then 27 ones and then 30 threes and whatever, and then add them all up? And I want a shortcut to get the mean and the standard deviation. We always want to be able to get the mean and the standard deviation quickly, no matter how they give me the data. Does that make any sense? It's such a great feeling when the teacher says that and everybody's like, no. If I give you a list of data, could you find the mean and the standard deviation? Of course you could. Now, as I promised, I'm not going to make you find the standard deviation of just a list of data points directly anymore after test 1. You with me? So, yeah. What we're going to do is we're going to figure out, what if somebody gave me data like this? I'm going to do it in the way that you are not going to do it, and then I'm going to develop the shortcut. So a lot of the work I'm going to do today is work you never have to do. It just explains why the shortcut works. Does that make sense? Okay. What you got, Jeff? What's that so far? Okay, that works. Beautiful. Okay. Can anyone tell me what this means? Like, how much of my data is zero? What percentage of my data are zeros? 10%, right? You guys see that? So this is sort of like a relative frequency. 1 out of 10 is zeros. 3 out of 10 is ones. You guys see that? So I'm going to write a list of data that would mean this. And then we're going to do the work and I'm going to develop the shortcut, and you're going to love the hell out of the shortcut very quickly. So one thing this could represent is, like I just said, there could be 1 0 and 3 1s, 2 2s, and 4 3s, right? Is everybody with me? How many of the numbers are 3? Out of how many total numbers? How many total numbers? 10. So 4 divided by 10 is 0.4. See? You guys with me? I could also have made 100 numbers and made 10 of them 0, 30 of them 1s. Wouldn't that also represent this? Do you guys understand? That's the simplest way to represent this. Okay. how would you calculate the average? Just tell me. What would you do? Add up all in, it's crazy. Add them all up. So I'm gonna do this. I've got 1 0 plus 3 1s is cool, plus 2 2s, plus 4 3s. So I got less shit to write, right? Because I got a crazy frickin' stats teacher that wants to see more work than I used to. Damn him, right? Okay. You guys all with me? Instead of writing 3 plus 3 plus, I'm just gonna write 4 times 3. Is everybody cool with that? Okay. Divided by 10. Okay, there's 10 data points. I like it. And if you just do that, you'll get the answer, correct? So I'm going to do old way. So what is all this? 0 plus 3, 3 plus 4 plus 12, right? 3 plus 4 plus 12 is 19. Divided by 10. So we get an average of 1.9, is that all right? Okay, all right. All right. So what's this new way look like? And the reason we're doing a new way, how did I write this list? Because this was like 1/10 and 3/10, right? If I had 0.157, what does 0.157 mean as a fraction? 0.157. What is that as a fraction? 0.157. What is 0.157 as a fraction? What is 0.1 as a fraction? 1/10. What's 0.15 as a fraction? 15 hundredths, right? So what is 0.157 as a fraction? So if I had a problem and they gave me, there were 0.157% was 1, and I want to make a list out of it, I'd have to list 1 157 times. Do you want to do that? No. So okay. So I am doing a problem that we could do the old way easy. I'm going to develop a new way that will work even if these become really gross. That sounds promising, correct? I always have somebody go, that was easy shit over there, man. Why are you doing all that weird shit? Well, because this is a really easy example. And I want something to work for no matter what. So what's the other way to look at this? See if you guys are cool with this. Wouldn't this be 1/10 of 0 plus 3/10 of 1? Is everybody cool with what's happening? Plus 2/10 of 2 plus 4/10 of 3. Let me stop for a minute. Mathematically, the math is just kind of laughing like, whatever the hell you want to do, human. Shit. I could totally take this and break it up. Yes? Is everybody cool with that? Totally, right? I could break it up. Now, can I find this stuff in here? Well, yeah. What's 1/10? 0.1 times 0 plus 0.3 times 1 plus 0.2 times 2 plus 0.4 times 3. So look what that means. All that means is I'm going to multiply across. You see that? That's the first step of the shortcut. And then what do I do with each thing? I add them all, right? So here I get 0 plus 0.3 plus 0.4 plus 1.2. And when you add all that up, what do you get? The AC is loud as hell. 1.9. It better be freaking 1.9 because 1.9 is the answer, right? You guys with me? So in the table, I just have to multiply across. Can somebody tell me how to title this column? What are we doing exactly? What are these? X's. And we're multiplying so what's this titled? X times P of X. Is that cool? Maybe? Does everybody see the connection just mathematically? I could just take the weights times the value. So I like to call these weights. Because what's the heaviest weighted piece of data here? 3. What's the next heaviest weighted piece of data? 1. Yeah, so those are the weights. So if I multiply each data point by how heavy it is, and combine that, it's going to tell me what the average is. Because each data point try to pull the mean towards it. It's kind of a nifty way to look at it. Okay. So that's how to calculate the mean. Then I want to figure out one more thing, right? Because what are the 2 things I want to always be able to calculate for any given set of data? I want to know where the center is, the mean, and I want to know the spread, the standard deviation, right? Yes?
So multiply across is five.
Yes, multiply across, add down is to find the mean. So let's see, 0, 0.3, 0.4, 1.2, and that's exactly what we just did there, right? You add those together, you 1.9. So can somebody tell me, what is the formula for mu? What was 1.9 exactly? You guys don't know because you can't even see. Where did I get 1.9 from? What did I do to get 1.9? Added what up? All the xp of x is correct. How do I show that in symbols? What does add them up mean in symbols? Sigma. I added up all of the xp of x's. There's the formula for the mean. It is a really nifty thing. It could just be me though. I know. A lot of what I consider nifty, you're all like, oh. Another name for the mean is the expected value. You guys sort of with me? Okay. Whatever the average is, that's what I expect to see. So if you know that the average height is 5'9", then you expect somebody to be close to 5'9". It's sort of like what you expect. Does that make sense? And what are the first 3 letters of this sort of? EXP, expected value, right? That's kind of cool. You got to admit it. We didn't like reverse engineering. We just got lucky that it actually tells you its name. The mean is the expected value, right? Okay, I like it. Still like negative reaction. I love it. It's so freaky. I've never seen it before. Okay. Let's try another one, just the mean, and then we'll talk about how to get the standard deviation. So here, what if I add this data here? What do you got, Jeff? 5, 7, 11, 16. 0.135.428. This is gonna suck, Jeff. You gotta really, you're really doing it to yourself here, buddy. What do you got, buddy? 372. Yeah, let's do that. That'll make it easier. 0.065, I believe. Wait. 7, 8. Let's see, 8, 9. Yeah, I think that should work. Somebody help me. What am I trying to make sure happens? What must happen for this to be valid? All the probabilities have to add to be 1. Can somebody double check me real quick? My hand is out of batteries. No, nobody? Okay. Oh, good. Thank you. By the way, if you need a calculator, might as well do that real quick.
8 equals 1.
Was it? 1? Okay. My brain is working. Anybody need a bar calculator? I got a worksheet we're going to do in a minute, so. Okay. How would you calculate the mean? What would you do? In fact, before we even do that, what's the heaviest weighted piece of data? Oh. Thank you. 7. And 11 is not too far after that, right? So the average should be close to 7. 11's going to pull it a little bit. Are you guys? I can kind of tell where the average should sort of be by what's the heaviest data point. If I just add these up and divide by 4, why is that not the correct average? If I just add these up and divide by 4, why is that not the correct average? How many 5s are there, for example? If there were 1,000 data points, how many 5s would there be? 135, correct? Yes? So you can't, if all of these were equally weighted, that would work. But 5 is nowhere near as heavy as 7. And 16 is definitely pretty freaking light. I don't know if you guys see what I'm saying. So you cannot just add these up because that's assuming there's one of each. Are you with me? If I give you a list and it's 5, 7, 11, 16, how do you get the average? You add them up. Is there just one 5? No. 13.5% of my data is 5s. So if I have 1,000 data points, 135 of them are 5s. Does that make sense? So, if I have 1,000 data points, right? I have 1,000 data points, and 135 of them are 5s. What percentage of the data are 5s? How many are 5s? How many are 5s? 135, right? That's what I said. Out of how many total? 1,000. 135 divided by 1,000 is 0.135. So physically, what these weights mean is exactly what I just said. 13.5% of my data is 5s. When you guys are making histograms, and you did a class, and you got a percentage, didn't that percentage mean the percentage of the data that falls in that class? Right? When you got a relative frequency. Didn't that mean the percentage of the data that fell in that class? Are you guys at all with me? I mean, we did a decent amount of that. Okay. That's exactly what this means. 13.5% of the data is 5s. 42.8% of the data is 7s. So why can't I just do 5 plus 7 plus 11 plus 16 divided by 4? 2 reasons. There's not just 4 data points. There can't be. And there's not just one of each then, right? Each doing shit. So let me try a different tactic. What's the average of 1, 2, and 3? 2, right? Is that cool with everybody? What's the average of 1, 2, 3, 3? Aren't they the same data points? Both of them have the data points 1, 2, 3, correct? Do they have the same mean? Why not? There's more 3s. So when you add them up, let's do it. So this mean is, something like it's a very small population. This mean is 2. Help me out. What's this mean going to be? What does that mean? I need more people doing this. Not on your head either, because it doesn't do anything.
That's a 2.
That's a 2. Thank you. Yes, it's trying to be a 2. Poor little dude. Poor little dude. Yeah, 2.25. Those are different, correct? And that's almost a silly question. You're all like, yeah, of course they're different, Jeff. You crazy dude. Right? You knew they were going to be different, didn't you? You with me? No, I'm sorry. If the answer is no, you can say no. I don't mean to be like pushing you, but 1, 2, 3 and 1, 2, 3, 3. There's no way they have the same mean. There's no way they can have the same mean because this has more bigger numbers, right? It's got 1 more 3. Of course it's not going to be the same. Are you with me?
Yeah.
Okay.
I was confused why you were just like asking. I didn't know how you got that.
On which part?
On any of it. I didn't understand why you were saying the average would be the same.
Well, so again, I don't have one of each, do I? Which one do I have the most of? 7s. I have the most 7s. So automatically, the average, it can't just be 5 plus 7 plus 11 plus 16 divided by 4, because that's treating it as if I only have 1 7.
Yeah.
I have more 7s than anything else, correct? So it's just like this. They're both the same. They all have 1s and 2s and 3s. But this has 2 3s and he has only 1. So of course the mean's going to be different. This guy, 0.135, is 135 out of 1,000. Is that cool with everybody? The really nifty thing about decimals, by the way, how many decimal places are there? That's how many zeros on the one on the bottom. Kabam, right? So 1.135 is 135 over 1,000. 135 out of 1,000. Is that cool? So if I had 1,000 data points, 135 out of those 1,000 would be the number 5. How many would be the number 7? 428 out of 1,000 would be the number 7. So there's no way the average can be the same as just adding these single digits and divided by 4. Of course it can't be the same, because it's not just 4 digits. It's not just 4 data points. Same way that there's not just 3, even just because I got the 3 repeated. Okay. Real quick. I just said it's not the answer, but just to show you, what would the average be if it was just 5, 7, 11, 16? Let's see how different our average comes out to be. What do you get when you average those? 39, 4. What is it saving from us?
9.75.
That sounds about right. Yes. Okay. All right. Let's see what we get here. So, do you guys see how you can even start thinking about how to put this in your calculator? If you put this in L1 and this in L2, what would L3 be? What do I want? X times P of X. So what would L3 be? L1 times L2. That's crazy sauce. This is not a very large sample, so you don't have to do that. You can just do each one. So help me out. 5 times this. What is that? Say again? 675? Sounds about right. And then 7 times this thingamajig? 2.996? And 11 times this dude? Did you jimble that shit? 4.092? And then 16 times this little dude? 1.04? You guys can all double check if you want to. Okay. And now how do I get the mean? Just add them up. It's almost too nice to believe. So let's see what the mean. It'll be really fun if it just happens to be the same. But I don't think so. Let's see. 6, 7, 8 point. It's roughly 8.6 or so. 8.803. So you guys get? How does our actual mean compare to the average of just those numbers? Ours is a little bit lower, correct? A little smaller. You guys with me? Okay, not a trick question. It's just smaller. Why does that make sense? What was the heaviest weighted data point? 7. And I know 11 is the next, but isn't 5 twice as heavy as 16? So these two together pulled the average down a little bit from where it normally would be to become that. Does that make any sense? What I just said, it doesn't matter. You could do all the work and not even understand what I just said. But if you understand what I just said, this makes more sense. These two together pull the mean down just a bit. If I would have made this sucker 0.4 and this one 0.1, then it would have pulled it even further down, because now the 5 would have been the most powerful and it would have pulled it towards it. It's almost like a gravitational thing. Okay, maybe. It isn't. I know it isn't. And I don't care, because it's a neat way to think of it. Okay. All right. So now, let's do this. Let's make a really basic thing, because we got to figure out how to calculate the standard deviation. And I don't want to use it on kind of freaky ass numbers yet, right? We know the formula for the mean if it's given to me in a table like this. Let's focus on what the hell the standard deviation is going to be. So anytime I'm given a distribution of data, we are going to have to figure out, okay, what's the shortest way to figure out the mean, and what's the shortest way to figure out the standard deviation? Because those two things summarize the data. If I know where the center of the data is, and I know how spread out the data gets, I know freaking so much about that. You don't have to tell me all the thousands of data points. Screw that. Just give me 2 numbers, right? Where's the middle, and how spread out is it? As soon as I'm done with this example, by the way, I'm going to unleash you on a little worksheet. So it's not just me speaking forever. So let's make some kind of nice data. Let's just do 1, 2, 3, 4. Sounds good. Let's make some nice probabilities just to introduce this freaky idea. Let's do 0.5, 0.2, 0.1. Okay. Why is this a valid? So here's what we call this. This is a probability distribution. Why is this a probability? Why is this a valid one? Yes, good. So the sum of px is 1. Check. And then there's another silly little one that almost seems silly to even check. What's the smallest the probability it can be? Smallest the probability can be? 0. What's the biggest it can be? 1. So either it definitely won't happen or it definitely will happen. There's nothing outside of that I know of. So then 0 is less than or equal to p of x is less than or equal to 1. Technically you should say for all x, but if you just write this out, understand what you mean. So those two things tell me it's valid. Very quick, don't even write this shit down, right? Don't even write this shit down. Do these add up to be 1?
Yes.
Totally. But why is this not valid? Because probably I get a 0 is what? 150%. You guys see that? And probably get a 1 is what the hell does that mean? People near me suddenly get 1. Like a dollar appears in the pocket when I walk near them. I don't know if you guys get that joke, but it's okay. So it can't be a negative probability. It can't be more than 100, even though together they make 1. That's why you need both of these to be true. Okay. Real quick, figure out the mean. I'll wait. Just take a minute and figure out what the mean is. Should probably drink some water too. Let's see. Yeah. I'm gonna catch up to you real quick. You're 1.9? Man, I just have a thing for 1.9 today. All right. Now, a little side note that will explain what we're about to do to get the standard deviation. What was the formula for the mean from the beginning? So here's kind of like the current one for if they give it to me like this. What's just the formula for the mean from the beginning? What do you get to get the average? You do what? You add them all up. Divided by the number of data points, right? You guys, what seems to be missing? Can you see the primary thing that seems to be missing here? Over n. See how there's no over n here? You guys see that? What's on the bottom of every probability? What was probability? The number of things that match what you're looking for divided by the total number of things. I really want you to get this. Do you see how this has an over n in it? Doesn't a probability have over n built in? Yes? If there are 40 people in here and 3 are left-handed, what's the probability I pick a left-handed person? 3 out of 40. Every probability has n on the bottom. You guys would? I really want you to see what I'm talking about. So these two are the same freaking formula. It's just that I suck the n in to the p of x. They're the same formula. Okay. Even if that doesn't make sense, it's okay. Just a little extra thing I like to think of. So, how did we calculate standard deviation before? Didn't we do? I'm not going to go back on my word. Didn't we do this and then we did this? Right. Then we added them all up, and then we divided by n. Remember that for the population? Are you guys with me? So just like there's an n already here, if I take these and I multiply by probability, isn't there also an over n built into that the same way? Maybe. So what I want to do, and what we're not going to do, because we're going to do something a little bit better, is I want to do this. I want to do that. Okay. So let me show you what we're actually going to do, because that involves a lot of stuff. Not that much, to be honest. I'm still going to show you this. Okay. So again, just to catch up on where we are. We have a way to figure out the center. Right now we're trying to figure out what the spread is. To figure out the center, I just took each data value and I multiplied it by the weight. So it kind of makes sense to get the standard deviation, I take each squared deviation and I multiply by the weight. The same way. Okay, so here comes the little bit of algebra that I said was in this class. Here comes a bulk of it, a lot of it. If you saw this in algebra, see how it's a part of that? What would you do? And I say, the instructions say simplify, right? What would you do? Does anybody remember how to simplify this? No, I can't just square it out of nowhere, right? How do you simplify? If you had to do this by hand, if you had to do this by hand, what would you do? Good, you would do 23 times 23. So here, what do you do? Right? And how the hell do you do that? Sure, the box thing, sure. Yeah, foil. Real quick side note about foil. That shit shouldn't exist. There's no need for foil. None of you think first, outside, inner, last. I don't think so, right? Foil is first, outer, inner, last. So much bullshit. Yes?
Where'd you get 23 from?
Made it up as an example of what to do. Yeah. I have something squared, correct?
Yeah.
A bunch of variables. So I gave us a number squared just to remind you what you do.
Okay.
If you had to do this by hand, you would do 23 times 23. So I want you to do this, so you're going to do one of these times the other one. That's what squared means. Okay. Foiling is just repeated distribution. What do I have to distribute? I have to distribute the x. What do you get? X squared minus x. Yeah? And then this guy gets a turn, correct? I don't need no freaking foil. Just distribute him and then distribute him. What's that? Another x u squared. Okay, I like it. Nothing amazing. So then I get x squared minus 2x plus o squared. Okay. And isn't this being multiplied by p of x? Yes? So if I distribute this, the very first thing I get is x squared p of x, correct? And I get other shit, don't I? Right? You guys with me? Okay, okay. Nothing, and again, we just foiled. So we haven't done anything like fantastic. It's just playing with variables. Nothing amazing. If I add these up, I'm going to get the standard deviation. So if I add these up, I'm going to get the standard deviation. All this other shit I get, when I foil this through, if you work with it, you actually get something kind of unexpected. Here's the formula you get. So the formula for the mean is sum of x p of x. That one's nice, right? The formula for the variance is going to be this. Well, it starts off as that. Let's try this again, John. I know. Hold on. See the x squared p of x, right? You can see that. The part I'm not going to go over because I'm not going to make this into a summation algebra class is how everything else just becomes minus the mean square. Sometimes I'll make that a bonus question on a test and see if somebody can work it out. Okay. So, an excellent question right now from one of you guys, and this would be the question if I was in this class. I would say, Mr. Waller, what does that mean for me? What does that mean for this guy, right? What am I going to have to do with this shit? Well, here's what you're going to have to do. Y'all cool with this data? We got the mean, correct? Look what this formula needs. This formula needs a bunch of x squared p of x's so I can add them up. Do you guys see that? This formula needs a bunch of these so I can add them up. So I need, instead of all that craziness, I need x squared times p of x. The way that I personally do that is I just do L1 times L3. If I do this times this, what do I get? What's x times x? X squared times p of x, right? Okay. You can't just square this. What's wrong with just squaring this column? Why is that wrong? If I just square this, what do I get? X squared p squared. It's not what I want, right? I want x squared times p of x. So if I just do this times this, what do I get? 0.5, 0.8, 1.8, 1.6. So then if I add those up, I'm going to get 1.3, 3.1, 4.7 maybe? But trust myself. Yeah, okay. Now again, how much of what we just done was me talking and giving examples and shit? Because sometimes the students like, my God, this problem's taking forever. I'm going to have to do this over and over. How much of the problem have I actually done? I mean, very little. There's very little work up here. It's just me explaining and explaining. You're like, good God, this guy every day is just on and on with how shit works. Okay. We're not done though. Because what's the formula for the variance? I haven't calculated it yet. Formula for the variance is sum of x squared p of x. We know that shit, don't we? What is the sum of x squared p of x? 4.7. Minus, what was the mean? 1.9 squared. So that's going to be the variance. Somebody help me out. What is that shit? Why can't you do it, Jeff? I don't know, man. 4 minus 3.6 plus 3.61, so 1.09? Look at me go. Whatever, Jeff, they pay you for that shit. Oh, yeah. It's my one skill. So then the square root of 1.09, it's like 1.0. I don't know. I'm not even going to try to make that shit up. 1.02, 1.03, 1.04. Okay. Now remember, standard deviation at least 3 places. So 1.044. All right. So now, blissfully, thankfully, I'm going to shut the freak up, and I'm going to give you. To do this, I have to go get it. I'm going to leave my camera rolling so I can hear everything everybody says. I'll be right back.
Peppa did it to me when we were talking with the chicken.
You would have been mad.
Oh wait, I think it's back. Okay, we got. We got double zero, so that's good.
I got the same thing.
And then the other
That's my homework. You gonna ask?
That's what?
You gonna ask if you have your homework?
Yeah, I mean, I've always like put together. I was gonna ask him and if they're missing or not. And if it's not, I would put it in the app. Like it's just.
Are you gonna redo it?
Well, unless I need a credit, like if I don't like, if it's okay, then okay, well, it's not the loss. It's like I'd at least give it a credit.
Well, it doesn't make us redo it.
Do it is very better than Oh, really? You think?
You need to look at it.
Take a look at
I'm pretty bad. I don't beat. Beat, that's pretty bad. Last year I graduated all A. The first time I left high school.
Did you see the new trailer for the new movie that's coming out? It's like the boy and the heron, and like it's pretty low-key, like the way they draw the birds is like it's pretty freaky.
Okay.
It's
I have not seen it, so I'm
no,
excited.
it's like it has like teeth, like the heron
Man,
has teeth and stuff.
Volleyball. Okay.
It's legitimately freaky.
Oh, I thought we were doing stuff. I thought we were doing, because I saw this was all filled in. I'm like, oh, I thought we were doing stuff.
Oh yeah. It's like the very.
Like this is terrifying. This is my nightmare. I'm actually tempted for a bird. Like if I see this, like yes, I'm like I'm ready for it. No, it's funny. I like see the it's Mr. Jeff. See, this is like it's crazy.
Can I get a calculator real quick?
Yeah.
I just couldn't find my keys earlier, so I was like,
Mr. Jeff.
I mean, you almost refer to it.
Oh, cool.
Yeah, it's like
That's sort of like Castle in the Sky kind of vibes.
Castle in the Sky. I'm just
Of course, I mean Nazca. I mean, come on.
No, oh, that's true.